Yeah, would like to talk a little bit about the knowledge action network on extreme events and emergent risks. Maybe a little bit of concept. I like to start this with this slide of a rosemary because I like it so much, and but I can't grow it in Jena. And why can I not grow it in Jena? Because, or not very well at least, it's not because of the mean temperatures or mean precipitation, mean climate, but it's really because of some very cold winters that happen every 5 to 10 years. And these are the kind of extreme events that kill this plant. And I think so. This is just a metaphor for the importance, I think, of extreme events when we think about a path towards sustainability, which is basically, of course, embedded in the sustainable development goals. And the point is that I think we also in the risk can't think that in the discussion, the role of climate extremes endangering the path towards sustainable development goals is maybe not very strongly still addressed. And on the other hand, it is also very evident that reaching towards sustainable development goals will also likely increase the resilience against climate extremes. So, if you think about that there is less poverty, more education, more overall health, and so on, and better infrastructure, this will all help to be more resilient towards extremes. But it is not entirely clear what would be the priorities, and so on and so forth. So there's definitely knowledge gaps. What we also believe here in this context, that is really important to link these three major frameworks, actually the Sendai framework for disaster risk reduction, then the SDG framework, and of course the action on climate change via the Paris Agreement, because they are all three parts of a coin, if you want, and that all would then lead actually to something what you would call risk-aware sustainable development. So not just sustainable development where everything is nice all the time, but we have to consider risk, and we're always thinking of risk caused by climate extremes. Of course, now we are in exactly the situation, not through climate, but through the pandemic, that exactly is hitting this on top. But I think we need to think about in the future that climate extremes will pose severe risks. I think this is recognized in general also by the UNDRR. For example, the Global Assessment Report 19 also synthesized that quite nicely, where they argue one should look through the systemic risk lens and go from managing disasters, how it has been done before, more to managing risk with some foresight also. I really would like to make the point. I mean, I think many, of course, you're aware of that, and many people are aware of that, of the risks, particularly imposed by climate change. But if you really look into the document, and I looked, for example, in the German document, the German sustainability strategy, what you can see there, and then Germany, I think, is a country that is relatively advanced, actually, regarding, at least says that Germany is advanced regarding sustainable development strategies. But climate extremes basically only mentioned 3 times in this 70-page report, and only in 3 resorts, like in the traffic, only 1 resort, only in the one on traffic infrastructure and digital affairs. If you look for disasters, it's actually only mentioned once. And risk is mentioned 8 times, but marginally here and there, and with totally inconsistent meanings. So that basically shows that indeed this awareness and in these strategic developments towards sustainability is not really there at the end. I think another example that actually a colleague from China, Planier, gave me is the thing of smart cities, which is very popular, and also these are of course very vulnerable to failures, let's say, in general. So this also needs to be considered. On the other hand, it is quite clear, if you look, for example, at the analysis of the World Economic Forum that's coming out every year, so the risk report, that natural risks and in particular extreme weather have been until 2019 always on the first two most urgent risks to be considered, and 2020 it was still on the first, or beginning of 2020. Next year there will be definitely some pandemics also, but you see also that 2020, if you look, all these environmental risks are basically all on the first five. These are basically the first five risks that have been identified. So I think it is something that is recognized not only as a kind of fashion after one event, but it's really something that is in the is consciously recognized. I think a really important challenge with respect to climate extremes, we think, compared to other hazards, is that we expect changing magnitude and frequency of those, and that basically means existing norms and beliefs that have protected societies against them or had led to resilience do not necessarily hold anymore. Okay, sorry, that this is in German here. So they also, just one other example, in this typical risk matrix where you have the likelihood on the x-axis and the impact on the y-axis. Here you see extreme weather and climate action failure also as being recognized by the world leaders, kind of in economic sense, on the top in both dimensions. So that is quite clear. And what they also recognized nicely for quite a while already, that we are really talking not about isolated risk, but really interconnected risk. For example, here we have this triangle between extreme weather, water crisis, food crisis, climate action failure. One could also add biodiversity loss here. And that is kind of connected to more societal risks, where involuntary migrations, social stability can happen, and then can lead to governance failure, both at national and regional or global scale. So this is really the importance of systemic risk here. Maybe just one empirical example from ODI actually. So we see, for example, that 60% of the deaths from natural hazard-related disasters occur actually in the top 30 fragile states, and in actually a much smaller fraction of states. Again, the GAR, this is another very nice figure, I think, that indicates the systemic risk or potential for systemic failure here in the context of food production. So the risk of multiple bread basket failure, where you basically see if we have multiple bread basket failures, it can actually then lead to systemic failure that expresses itself in many different ways. Another view that we actually have is that if we think about risk, is also a systemic view. We should often climate risk are directly transferred to the anthroposphere, and often it's ignored that there's a biosphere or land surface and oceans that actually mediate those risks. So there might be impact on the biosphere, but there are also solutions from the biosphere. If you think about flooding and so on, if we shape the land surface in a way that there are more forests, for example, or less straight rivers, this can avoid, for example, flood. That is also well known, but there are also other more complex examples. If you think about forest fires, I will come back to that. And of course, there is then also the feedback through the biosphere into the atmosphere, like bioagriculture and so on and so forth. So I think that's really important that we look at these, at least at these three spheres, if we think about systemic risk and risk impacts. Yeah. So one concrete example, if we look into the Russian heat wave, I think that showed very nicely this character of multiple hazards and also compound events. So that basically started from a high pressure system. You see here this omega synoptic situation with high pressure on top of climate change. And that led then to exceptional heat and drought during this year or during the summer, which led to vegetation stress as a cascading effect and the desiccation of vegetation to forest fires that in turn created quite huge air pollution. And only the synergy of the heat and the air pollution actually led to the really strong excess mortality, particularly in the cities, with more than 10,000 fatalities. And another kind of causal cascade is certainly via the production systems of crops. So a strong crop failure happened regarding wheat in particular. And that economists tell that this had quite an effect on the wheat prices with quite some volatility. And it's not proven, but there are indications that this caused also or led as a risk multiplier for the social stability, leading to the Arab Spring. So you see basically, yeah, I mean, this is exactly the example of systemic interactions and risk with sometimes distant effects, also spatially distant effects compared to the event. Okay, maybe I skip this because I think I'm a little bit running out of time. But if we have this systemic perspective, it also leads also system dynamics also often lead to counterintuitive effects, which is actually in this case nice from the resilience point of view. So there has been a study regarding effects of droughts on nutrition of children in East Africa. And you see, well, if you have a mild drought, okay, there's not so bad the situation, but if you have moderate drought, it's becoming worse. So more wasting of children, so they basically are underweight then. But if the drought is becoming very severe, actually it goes down again. So that we wouldn't expect. We would expect a direct effect, a strong kind of a strong effect on the droughts that will become worse. But what would be an hypothesis here is that we do have an interaction between the natural systems and the human and societal system. So the classical, maybe even natural science point of view would be, okay, more drought, more malnutrition, and that causes wasting and mortality, and more drought, more mortality. But obviously, if there is stronger drought, there is also stronger risk perception, both nationally but also internationally. Which could trigger help, and then if you have more help, you have less mortality. So you have at the end we have actually negative feedback here through this system dynamics, if you want, via the risk perception. So I think that is actually quite important to note, and one can also exploit that. In the CAN, we were actually also wondering a bit, what are the obstacles to societal resilience versus climate extremes? And one really has to say there are parts where actually knowledge is missing. Last year we had a conference on that, and it was clear, yeah, there is also still uncertainties regarding hazards and exposure, but in particular, what causes vulnerability is still a big scientific question. On the other hand, on the other branch, there is also existing knowledge, but often missing action. And this is, of course, then one can ask a question, okay, what hinders certain implementations? It could be technical, economic, cultural, psychological, and or political factors. And that at the end also kind of can also be interesting or important research questions, but also needs, of course, we need to have, of course, have also more transfer of knowledge. A nice figure showing that from Brian Goling from Highweather, who's also part of the development team, basically shows this how he calls to become resilient, you have to cross how he calls it the 5 valleys of death. So it's basically, it's not enough to have good observation and have good weather forecast, but then you need to have a hazard forecast. The next bridge is to get to an impact forecast. The next bridge is then having a good warning system in place, early warning in particular. And then, of course, even the warning is there's not always the case that the right decision is being taken, which relates then to psychology. So this is an important kind of showing again the needed interdisciplinary approach here if you want to achieve resilience, and that's also something that we embrace in the risk card. Maybe okay, let me also skip that, but I think really psychology can also play an important role. We believe if you think about how behavior here on the right hand side is actually emerges. One needs to basically have both the perception or the recognition that there's a threat, so you have to have a threat appraisal. But that's not enough. You also need to think that you can actually cope with it, and you have that you have strategies. So both has to come together, bring the intention that you want to do something against it, and that then causes the behavior. So there's quite recent psychological research still going on. I think this is really important to incorporate into the resilience discussion. Also, artificial intelligence, not of course for data science and analyzing data, but it's actually also important for communication. Quite a leading group in machine learning from Banjo in Canada actually made this a nice paper where they basically tried to let AI imagine an image based on a current image. How would the image look like with flood? So they that's on the right hand side, and this is much easier to grasp probably for people to see that there's a risk compared to just some abstract numbers that water levels will be 2 meters higher than normal or something like that. So this would be very visual and very directly a direct way of communicating this. Okay, so I would like to talk a bit about concretely about the knowledge action network, which is important to note that it started, actually the idea started a bit from activities that I had in Future Earth, but we early on realized that it would be actually nice to bring together here the three major programs, the World Climate Research Program, integrated research on disaster risk, and Future Earth. You may know Jana Tillmann also, who's in IRDR. And what is the idea of the risk count is basically really to bring together these, let's say, 3 different realms of approaches, mostly scientific in the first place, so more socio-economic ones with governance, history, archaeology, health, psychology, then more natural science related ones, the green ones, but then also methodological approaches that can basically work as a unifying maybe approach in modeling and complex systems, risk and probability approaches, and AI and data science. And the idea is basically to build a global build global knowledge on emergent risks and extreme events to address systemic, complex, and cascading risks, and really to be an open and provide an open platform for scientific communities. And then also be a kind of advisory body for governance and UN bodies and so on. I think here it's just a little bit, it's very similar, but maybe the focus is a bit clearer here. So really the focus of that Khan is risk cascades that are originating from climate and weather related hazards. So we were thinking about, should the risk Khan also be on financial risk and so on, but that would be very broad. And so we thought at the beginning, at least, a good focus is to include also non-natural risk cascades, but the origin, we should think about the cascades stemming from natural hazards like climate and weather related. And of course, also from the synergy of climate and weather related hazards and other natural hazards, like now we have COVID pandemics, but also climate and weather on top of an earthquake and so on and so forth. And so basically it's a multi-hazard and a systemic approach with an emphasis on climate. And why climate is important, we believe, because it is a moving target where things actually change over time. Yeah, so here's another view on this risk perspective, how we see that with the three kind of circles making up the risk at the end. And I wanted to quickly show you the risk. So basically, well, this is our webpage. You can have a look. Groups established 9 now, on all on different topics, and all with the idea of having a focus on the systemic aspects. Yeah, so I won't have the time to go into detail, but these are covering actually quite a nice range. And what we're doing is mostly having in terms of events, mostly scientific events, like sessions on scientific conferences. Here, just the next one. So the next ones will be the European Geophysical Union, where there are these 4 sessions planned. What is very successful is the webinars that are organized by several working groups. Most of them are actually also recorded. This is really a very successful format where we get a lot of also from external people. Maybe quickly, the development team, you might know some of the members. So I mean, first of all, together with Jana Zillmann and Felix, I'm currently chairing the risk Khan with Yu Ting. Here as part of the development team, Brian Golding I cited, and it's also quite a broad range of people spanning from governance to risk assessment and natural science, political science. So we do have quite good discussions here also. I'm sure you know a couple of those people. And thanks to Yuting, we also have a Twitter account since yesterday. Yeah, so feel also free to follow us, of course. Yeah. So basically, I end with this last slide, which I find really telling, from Gutierrez last year in January. What he said is, if I had to select one sentence to describe the state of the world, I would say that we are in a world in which global challenges are more and more integrated and the responses are more and more fragmented. And if this is not reversed, it's a recipe for disaster. I think this was also still under the perception of the Trump administration. So I think things are actually becoming better because the US is playing a big role in this question how the world functions. And I think from the scientific point of view, I think it is important that we contribute, that this is not becoming true. And that means that we address this topic multidisciplinary, but also with integration from many regions. And that's why I'm also really happy that you reached out and want to discuss with Riskan how we can better work together. So thank you.
Thank you, Markus.